statistics. So can we give a quite 5 minutes to revise the last lecture? So what is statistics?
The interest.
Interest.
No, not the interest, like
What is
the
statistics?
data of the whole picture.
You should
The whole
include
data.
data of the whole, not only about data. Data is,
Analyzing, summarizing, and
yes, basically statistics is that you just collect the data, collect the information. So it's like obtaining the information. Remember it was 5 steps. What were those? Obtaining the information, summarizing the information or the data, the information we call data, presenting the information in any tablet form, tabular form or any form, analyzing the information. So all of this process combined together inform statistics. So what is statistics? In which we have set of methods for obtaining, organizing, summarizing, presenting, and analyzing of the data. So what is data?
gathered information.
Data is the information gathered. Okay. So we learned about 2 types of data. What are 2 types of data?
Quantitative and qualitative.
It's quantitative data and qualitative data. Okay, so we learned about quantitative data. What is quantitative data?
That kind numerical values.
Yes, and it also have 2 types.
Continuous
Discrete.
and
Very good. Discrete or
discrete.
continuous. So what
Continuous.
is discrete and what is continuous?
Discrete is like straight 1, 2, 3, and continuous like in decimals.
Okay, so now what is qualitative?
Cardinal and nominal.
Nominal. Very good. So what is the meaning of cardinal and nominal?
Cardinal has no orders and ordinal has order. No, sorry.
Nominal has no orders and the other one has orders.
Okay.
So what is sample?
A small part of the population.
What is population?
Uh, Total number of the
The collection of all the items is called population, and the
collection.
small part from that population is called sample. Very good. So the distribution of the data set tells us what values a variable takes and how often it takes these values. In the sense, value doesn't necessarily have to be quantitative. For example, female is a value of the variable gender. There are several techniques we can use to display data in order to better study its features. So now we are going to learn how to display the categorical data. Bar charts display variables values on one axis and frequencies in the other axis. There are spaces between the bars so as not to imply community. So what is happening? We are going to learn about it. What is a bar chart? You might have learned it before also, the bar chart. So
Yeah.
this is a bar chart which is used to display the data. So
Mhm.
in the bar chart, we have what is the meaning of frequency, the word frequency. Have you heard the word frequency before?
Yeah.
Okay, what is frequency?
The number of
Number of
something.
times something occurs. So number of times something occurs is called frequency. So in a bar chart, we have 2 coordinates. One is the x coordinate and one is the y coordinate. The frequency is always plotted on the y coordinate. And the other thing for which the frequency is plotted is called variable, and that is plotted on the x coordinate. So what did we learn? That there are 2 coordinates, x coordinate, y coordinate. We always
Yeah.
plot the frequency on the y coordinate. We plot the variable on the x coordinate. Did you get it?
Yeah.
Now frequency tells us how many number of times a particular thing occurs. So if it is block, this is representing 10. So it means block occurs 10 times. Conservative people occurs 37 times. Liberal people occurs 25 times. NDP occurs 20 times. Green occurs 10 times again, others occur 0 or 1 times. Okay, so this is how a bar chart represents our information in the form of a chart. Is everything clear?
Yeah.
So it is representing categorical data in the form of a chart. Categorical data can also be represented in the form of a pie chart. Now we have learned about bar charts, but now we are going to learn about pie charts. Okay. So what is pie chart? Categorical data. Pie charts give a visual representation of the relative frequency of the observed values for a categorical. So now the whole of this categorical data is 360 degrees. So what we're going to do, block one. So we have to find in the degrees form, that how many block, how many conservative, how many liberal, how many NDP, how many green, and how many others. And then we will color or shade those portion of the circle. And this will represent us the data in the form of a pie chart. The most benefit of pie chart is that we will see that the blue color is the most common, the dark blue. So we know conservative people are the most one. We know black color is the least common, so we know that the others are the least one. So we can visualize our data very clearly in the pie chart. Okay, so what is next? Test scores for a class of 40 chemistry students are ordered and shown below. So these are the test scores for the 40 students of those are studying chemistry. So like 40 students, there are 40 students and there must be 40 scores obviously. So like there's any one student in the class who scored 31, another student scored 37, another scored 40, another scored 74, another scored 92, and another scored 98. So these are the 40 scores of the 40 different people who are studying in the class. Now,
Yeah.
consider the following frequency distribution of the data. So now I'm not going to show you this answer and I'm going to give you the question to do it by your own self. So you have to make a frequency distribution, and how you're going to make it, you will first make scores, the scores that the students are scoring. And then you will make another column, and that column is going to represent the frequency. Okay. Okay, so you are not going to write the frequency for like 31, 32, 33. So that would be very difficult and you have to write 40 numbers over 31, 32, and 40.
Yeah.
So that would be very difficult. So we are going to make the groups and that would be very easy. So let's say that which is the least frequent, least scores that a student get. What is the least score? You have to now
31.
give a very good focus on this data, okay? You have to focus on this
Okay.
data. Now tell me what is the least score?
31.
31 is the least. So we can take 30 and we can make the grouping of the 10 digits. So maybe 30 to 40, 40 to 50. Okay, tell me the highest score.
98.
98. So we can make it 100. 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Okay, so we have make this grouping and this grouping will help us build up the frequency very easily. So now tell me the number one is 31. So 31 lie in which group? First group.
30. Yeah.
So before writing the frequency, we will make another column. This is just to make our work very easy. We will draw the tally marks. Also, we will learn how to draw tally marks. So one is the 31. So we will draw one line over here. The next one is 37. So 37 lies again in the first column. So we will draw another line over here. Then it is 40. 40 lies again in the first column. So we will draw another line over here. Then it's 44. 44 lies in the second column. So we will draw one line over here. 49 lies in the second column. So draw another line over here. Okay, tell me 50 lies on second column. 51 lies in which column?
Third.
Third one. 53 lies in which column?
Third.
56 lies in which column?
Third.
56 again.
Third.
62.
Fourth.
64.
Fourth.
67.
Fourth.
67 again.
Fourth.
68.
Fourth.
Okay, we have one thing that it's 1, 2, 3, 4. When it's fifth line, we will draw a line like this. So it is easy to represent that these are 5 lines. Okay, next is 68. Which one? Fourth one. So we will do it next. We will again make a grouping of 5. Okay, then 69 again in this one. Then 70 again in this one. Okay, then 71, the next one. 72, the next one. Are you getting it?
Yeah.
73, it's easy. Next one.
Mhm.
73 again, this one. Now 74, so it's the fifth line, so we will move it like this. Now 75, 77, 78, 78 again. So it's 81. It's 82. It's 84. 84 again. 87 again. We're going to fifth line, so we will do it like this. So 89. 89. Now 92. 92. 94. 95. 96. 98. So why did we draw these tally marks? They're going to help us count the frequency. Okay, let's count the frequency. How many tally marks here? 1, 2, 3. So the frequency is 3. 1, 2, 3. It's 3. 1, 2, 3,
4.
4. Yes. So this is 5 plus 3, 8. This is 5 plus 4, 9. 5 plus 2, 7. 5 plus 1, 6.
6.
So let's count it total. What should the total come?
Then, I'm sorry.
What should the total
Um,
of the frequency come?
40.
40, very good. It should be 40. If it's not 40, we are wrong. So
Yeah.
3 plus 3 is 6, 6 plus 4 is 10, 10 plus 8 is 18, 18 plus 9 is 27.
34.
Yes, it's
40.
so if it's 40, we are correct. If it's not 40, we are wrong. We have missed any number over here. So total of the frequency should be the total of this. It's always the case, okay? So in this
Okay.
example, we have learned how to make the frequency, how to draw the tally marks, and how to write the scores. So are you getting this?
Yeah.
Any problem up till now?
Nope.
Okay. So this is the frequency that they have just made for us, and we have already done this. Okay. So next is you 13. We are done with 13. Okay. So 14. Where is 14? What is this happening always with me? 12. Okay, 14 is here. Qualitative data. Frequency distribution is a count of how many of our data values fall into various predetermined classes or intervals. So what we have made this, did we make like this 30 to 40, 40 to 50? So
Yeah.
we named these intervals or we named these classes. These are the two names of these things, okay? We
Okay.
choose the intervals ourselves. So you know that we choose the interval ourselves. We determine the lowest one. We determine the highest one. And then we
Mhm.
choose the interval of 10 will be best for us. So intervals is chosen by us. There is no correct
Okay.
choice of intervals, but we construct them in such a manner that we get a nice picture of our data. So we usually take the interval for 5 to 10. So if I have a data starting from 30 and ending on 50, so it means I can take from 30 to 35, 35 to 40, 40 to 45, and 45 to 50. Why? Because we have a very small data, so 4 of the intervals will be enough. But in this case, we have a big data, so interval each of 10 is good. So interval is
Yeah.
something we have to decide according to our data. If data is very short, we can take the interval of 5. Otherwise, we can take 7, we can take 8, we can take 10. Okay?
Okay.
This is something decided by us. Okay.
Do we need to take percentage also?
Why?
I'm just asking.
No. For the frequency?
No, for this example, the 40 students.
So what kind of percentage is needed? For this example, we just need to plot the data in the form of a frequency distribution. So there is no need of percentage in this example.
Okay.
Okay, because we just need to make the class intervals and plot the frequency.
Okay.
Okay, so quantitative data. Our first interval must include the lowest data value. Obviously, the first interval should include the lowest value, that is a minimum one, and the last interval should include the maximum value, that is the maximum one. All intervals should be of equal length. Okay, so this is the rule that you can make the interval of any length. Either you can make the interval of length 5, or length 6, or length 7, or length 10, but they should be in equal of length. All of the intervals should be of equal length. Not
Mhm.
that each interval includes the left endpoint but not the right. So obviously there should be 30 to 40. So the next interval is from 40 to 50. So the left, these two are same. Then it's 50 to 60.
60.
So one of the interval left one will always be same.
Okay.
Okay. To avoid this problem, we could create non-overlapping intervals 30 to 39, 40 to 49, but we would like the frequency distribution to reflect the continuity of the data. For example, if a student score of 59.5, there would be no interval containing this value. So obviously, if we will go like this, 30 to 39, and the next is starting from 40 to 49. So if student score 39.5, where will it go? Either here or either here. So there will be no space for him to going. So therefore, we prefer this
Mhm.
thing. First in the end, first in the end, first in the end.
Okay.
Okay. Note that there are in fact two types of quantitative variables. A continuous, this is what we have done
Mhm.
yesterday. Continuous
Yeah.
variable can take any value within a given range. Example of continuous variables include weight, age, distance. Because weight can be 5.2, weight can be 55.2, age can be 2 years, 0.3 months. Distance can be any kilometers. So these are continuous variables because they can take the values in the decimals. Discrete variable can only take a countable number of values. Examples of discrete variables include the number of children in a family. Is it possible that a family has 2.5 children? No.
No.
It can be either 2 children or 3 children. The number of days of rain in a month. Is it possible that there are 2.5 days in a month? It can be either 2
No.
or either 3. The highest denomination of bill in someone's wallet. So all these examples are of discrete variable when there is no choice of decimals. They only take the countable numbers. If there is any confusion, I can stop and just guide you.
No, all good.
Everything is going good?
Yeah.
Great. Okay. Okay. Let's do a few more examples from the book.
All right.
Okay. Use the following information to answer the next three exercises. A Lake Tahoe Community College instructor is interested in the mean number of days Lake Tahoe Community College math students are absent from the class during a quarter. What is the population she is interested in? Okay. You have to answer question number 50.
What are the population she is interested in? Or like
Read the two lines that are given above.
math students. Sorry, math students.
Math
D.
students. So this is a population she is interested in. So answer is the D one. Consider the following. X is the number of days a Lake Tahoe Community College math student is absent. In this case, X is an example of.
Wait. Variable.
Very good, variable. The instructor's sample produces a mean number of days absent of 3.5 days. The value is an example of.
Example of statistic.
Very good, statistic. So it means you really know that we have done yesterday. Good one. Okay. For the following exercises, identify the type of data. Let's see this. Quantitative discrete, quantitative continuous, or qualitative. Okay, there are three options. Number of tickets
Okay.
sold to a concert.
Quantitative, discrete.
Discrete. Because tickets can't come in the decimals.
Yeah.
Percent of a body fat.
Quantitative, discrete.
Percentage of a body fat.
Discrete.
Fats can be in decimals or not.
Mm, yeah.
Yeah. Okay.
Mm-hmm.
Next. Favorite basketball team.
Qualitative.
It is qualitative. Okay. Next is time in line to buy groceries.
Continuous.
Continues. Quantitative continues. Number of students enrolled at Evergreen Valley College. Number of
Discrete.
discrete. Number of students are always discrete. Number of students, number of people, number of children, number of adults, any number of people typed in is always discrete. Most watched television show.
Qualitative.
Qualitative. Okay, brand of toothpaste.
Qualitative.
Qualitative. Distance to the closest movie theater.
Mm, continuous.
Yes, distance is always continuous. Age of executives in Fortune 500 companies.
Discrete.
Age.
Age.
We just discussed that age can be continuous.
Oh, sorry.
Age can be continuous, okay? So it's quantitative continuous. Number of competing computer spreadsheet software packages.
Age.
Hmm? Number of competing
Discrete.
discrete, yes. Okay. The next is use the following information to answer the next two exercises. A study was done to determine the age, number of times per week, and the duration of resident use of a local park in San Jose. The first house in the neighbor around the park was selected randomly, and then every eighth house in the neighborhood around the park was interviewed. Number of times per week is what type of data?
Statistic. I'm sorry. Continuous. Discrete.
Number of time per week is discrete one.
Rotan is rotan.
Okay. Duration, amount of time is what type of data?
Continuous.
Continuous. So this is the basic questions that whenever there is number of times per week, per month, per year, whatever, you're always going to choose discrete. This is a hint for doing the questions. And whenever there is some duration given, duration about amount of time or something amount of hours, amount. So this is always going to be continuous data, okay?
Okay.
Okay, read question number 65. What are they saying?
Airline companies are interested in the consistency of numbers of babies on each flight so that they have adequate safety equipment. Suppose an airline conducts a survey over Thanksgiving weekend. It surveys 6 flights from Boston to Salt Lake City to determine the number of babies on the flights. It determines the amount of safety equipment needed by the result of that study. Using complete sentences, list 3 things wrong with the way the survey was conducted.
Okay. So what are they saying? Airline companies are interested in the consistency of the number of babies on each flight so that they have adequate safety equipment. So they are interested in the consistency. Suppose an airline conducts a survey over Thanksgiving weekend. It surveys 6 flights from Boston to Salt Lake City to determine the number of babies on the flight. It determines the amount of safety equipment needed by the result of that study. Okay. So using complete sentences, list 3 things wrong with the way the survey was conducted. So, what were the wrong things?
Mm.
The first wrong thing should be
On Thanksgiving?
the survey was conducted using 6 similar flights.
Ah, yeah,
So, survey should always be conducted using different flights or different items. Okay, what is the second wrong thing? The survey cannot be a true representation of entire population. Survey cannot be a true representation of entire population because they conducted the survey from the same flights, so it cannot represent the entire population of air travelers. Is it fine?
yeah.
It is the third thing.
Happened over the
Conducting,
weekend.
yes, good. Conducting all the survey on the weekend won't produce the good results. Conducting all survey on weekends won't produce
The results.
good results. These are the 3 things that are wrong with the survey. Using complete sentences lists 3 ways that you would improve the survey if it were to be repeated. So you are given a chance to repeat the survey. So how you're going to make the things better this time? B part. Number 1.
Mm,
Conduct the survey during different times of the year.
yeah,
Number 1. Survey
different flights.
during different time of year. Number 2. Conduct the survey from different flights in different locations, various locations, because they're using only one location. So they're using Boston to Salt Lake City. So it's wrong. Conduct survey, different flights using different flights and various locations. Okay. Number 3. Conduct survey on different days of the week, not only on
Yeah,
weekend, days of week. So these are the 3 things that should be done to make the survey more better. So service should be diverse. It should be from different flights, different days, different time, different locations. That will give you the more better result. And that will pick the picture of the entire population in front of you. So is it clear?
yeah.
Okay, let's read something more. We did this continuous variable and discrete variable. Yes. Okay. So now
Yeah.
quantitative data. Okay, a frequency distribution can be converted into a relative frequency distribution. Now we have already learned the first two columns of the, we know how to make the intervals if the data is given.
Yeah.
We also know one more thing, how to make the telemarks, and we also
Mm.
know the third thing, that is how to write the frequency. Okay, so we know these two
Yeah.
columns. We now need to learn how to write the relative frequency. So relative frequency is the frequency divided by total frequency. Okay, so it's 2
Mm.
divided by 40, 3 by 40, 5 by 40, 7 by 40, 10 by 40, 7 by 40, 6 by 40. So relative frequency is always the frequency divided by total frequency. The following is a histogram for the set of score of data. Okay, first come to the next slide. Okay. By dividing the number of data values in each set class by total number of data values, we get the relative frequency or proportion of individuals in each interval. Proportions are values between 0 and 1 inclusive and are decimal representation of fractions. Proportions convert the percentages when multiplied by 100. Note that the proportions for all intervals must add up to 1 since 100% of the data values are continued in this distribution. So whenever we write the things in the relative frequency or in the proportion, so they always, when we count them all, they should always get 1. If we are not getting 1, it means we have done some mistake. So there is two hints. If we will count the total frequency, it will be equal to the total data given. If we will count the total relative frequency, it will be equal to 1.
Okay.
It must be equal to 1. If it's not equal to 1, there is some mistake done by your calculations. So the next is histogram. If a frequency distribution is representation of quantitative data, we can conduct a more useful and more commonly used display known as histogram. So another display used to represent the quantitative data is histogram. Histograms are useful when we need to work with a large amount of data. They are graphical displays of the count or proportion of data values falling into each of several intervals. So let's learn how to make the histograms. Okay. Following is a histogram for the test score data. So I'm going to show you the histogram. Okay. So what happened in the histogram? Always whenever we have to make any diagram in the statistics, we will write the number of count, number of frequency on the y-axis. So again, there are two coordinates, x-axis and y-axis. And number of count is always going to come on the y-axis. So here is a test scores from 30 to 40. So this is a range. So whenever we have range of data, it is students who score from 30 to 40,
40.
we will make a box. Then the next interval is starting from 40 to 50. So the line continues from the same line, 40
Mm.
to 50. The next start from 50. So line continues 50 to 60, 60 to 70. So in this way, we make a histogram. There is not much difference. In the bar chart, we make the separate parts, but in the histogram, we make the intervals like this. A histogram is the form of a bar graph with no spaces between bars so as to reflect the continuity of the data. So in the bar graph, there is a spaces between the bars, but in histogram, there is no space between the bars. The base of each rectangle represents the length of the interval, the height represents the frequency. So we know that the base is representing the length and the height is representing the frequency of the interval.
The,
Yes?
what was the length?
What was the length? This is the histogram. So the base, for example, 30 to 40 is the length. This is the
Uh-huh.
length, or
Oh,
this
yeah,
is
okay,
the
got it.
class interval. We can call it the length or class interval. So it ends over here on 2. So 2 is the frequency or count. 2, 30 to 40. Okay. Now let's suppose next is 50 to 60. So 50 to 60 is from here to here, and the frequency is 5. So it is going to end on 5 like this. Got it?
Yeah.
Hello? Can you tell
Hello.
me how to make bar graphs and histograms?
Explain it.
Yes, just explain me in your own words.
Uh, Bar graphs. I mean, they both are mostly similar. X and Y coordinates.
Yes, good.
Uh, for histographs, you can write the amount, like
Okay.
that varies between them, like 30 to 40 or 50
Yes,
on the
and then
length, and then the frequency on the sides,
good.
so which will determine the height of it.
Okay.
The
And histogram, there is no spaces between the bars.
Yeah,
Okay, so there is only 1 minute left. So after the now you are going to call me. So on the new
okay.
Zoom, we will start the questions now. 50 part-time students were asked how many courses they were taking this term. The incomplete results are shown. Okay. So now the course number one, course number two, course number three. Course number one was taken by 30 students. Course number two is taken by 15 students. How many students will take course number three?
5.
How did you calculate it? 5?
It'll be 45, then minus 50. So 5 students left.
Yes, because total are 50. So we subtract 30 and subtract 15. So we get 50, subtract 45, and we get 5. Very good. Okay, now you know how to calculate the relative frequency. So tell me the relative frequency for this and this.
Uh, okay, so 15 divided by 40.
Yeah. 40 or 50?
50, I'm sorry. Give me a second. Okay, 0.3,
Okay.
0.1.
It's 15 divided by 50 and it's 0.1. It's 5 divided by 50. So its total is 0.6, 0.9, and 0.1 is 1. So the total should be 1, then it's the correct answer and it's 1. Okay. So what is cumulative relative frequency? For cumulative relative frequency, write the first one same. For the second one, add the first one. 0.6 plus 0.3, it will give you the second one. It is equal to
10, 1,
0.6 plus 0.3,
9. Sorry.
0.9. Then in the next, what you're going to do, 0.9 plus the next one.
0.1,
Yes, it would be 0.9 plus 0.1. What you will get?
1.
1. So in cumulative relative frequency, you will get 1 in the last box. In the last
Mm-hmm.
box, you will always get 1. Okay. Okay. So fill in the blanks in table. What percentage of students take exactly 2 courses? So how many students take 2 courses? What percent of students take 2 courses? Okay, so the 2 courses are taken by 0.3 students, and if we will multiply 0.3 with 100, we will get 30%. To find the percentage, we can multiply the relative frequency with 100. So what percentage of students take 2 courses?
So wait, 0.3 multiplied by 100?
What you will get?
300?
No, beta.
Sorry,
You can use calculator in statistics.
30, sorry.
30. So it means 30% of students take 2 courses. Okay, to find the percentage, just multiply by 100. What percent of students take 1 or 2 courses? So for one is how to find for 1 courses. Only tell me for 1 courses.
10.
How?
Since it's 1 multiplied by 100.
Why 1 multiplied by 100? How many students are taking 1 course?
Oh, I'm sorry, 0.6. I
0.6.
was thinking 3.
So it's 0.6 multiplied by 100. What
100.
we will get?
60.
60%. Okay. So how many students take 2 courses?
30.
30. So how many take 1 or 2? It means it's 60% plus
Mm.
30% because it's 1 or 2. So it's going to be 90%. So how many students take 1 or 2 courses? 90% of the students. Are you getting this percentage thing?
Yeah.
Okay. Coming to 81. Now fill this question, 81. What will come over here in the third blank?
The blank 81, right?
81.
What's the total? 60 adults, okay. Eleven.
11. So the total is 60. From 60, you subtracted the sum of all these and you get 11 over here.
Mm.
Okay. Next, come to the relative frequencies.
Yeah.
How to find the relative frequency?
0.3. 18
18.
divided by 60.
18 divided by 60. Okay, 0.3. Next,
0.183.
0.183. Now add them all and see if you are getting one or not.
Should I add the zeros too, of like 0.4500, or should I ignore them?
Why should you ignore them? You will
No,
add
just
all of the
asking.
relative frequencies to get the result 0.45, 0.3, 0.18, 0.05, 0.1, all of them, all of this column, add all of this column.
Okay. Okay, for the frequency 11, it's 0.18, then 6 times 3.
You can take 2 times 3 over here. Are you adding them?
Yeah, yeah, I'm getting 1.
Okay, great. Come to the cumulative relative frequency. What should be the first one?
0 will be 0.4500.
You call it 0.4500. After decimal, you have to speak every digit separately. Okay, what is the
Okay,
next one? It would be
0.4500
0.4500 plus
plus
0.3.
0.3.
Yes.
0.75.
Okay, next.
0.933.
0.933 plus 0.05.
Yeah. 0.9833.
Okay, what is the last one?
0.9833 plus 0.0167. 1.
1. Good. So now you will tell me the answer for B part. What percentage of adults flossed 6 times per week? I'm giving you 1 minute. Hardly.
What percent? 5%.
5%. So how did we get it? Because what percentage of adults flossed 6 times per week? So 6 times per week is giving 0.0500. So it's
Yeah.
0.0500 times 100, which is giving you 5%. Good. What percent flossed at most 3 times per week? So how to find at most?
At most 1.
What is the meaning of
Wait.
the word at most?
Maximum,
Maximum. Good.
which would be the 0 per week.
So tell me what will be the answer? How much, which values are you are going to add?
Oh no, okay, flossing. Okay, my bad. It will be the 7th week.
7th week?
I
No.
mean,
What percentage flows at most 3 times per week? It means at most means it can float 3 times per week, or can float 1 times, or can float 0 times. At most means maximum will be 3, but all the values less than 3 are also possible. Okay, so there are two words, at most, and one word, at least. They are very important in statistics. At least 2 means less to less it's 2, but more than 2 all are included. At most 3, it means maximum 3, but less than 3 all are included. So now
also at
here
most
there,
means 3.
yes, so it's taking the word at most. It means the maximum is 3, but less than 3 all are included. For 3, what percentage? For 3, 0.18%. 1833 times 100%. Plus for 1, it's going to be 0.3 multiplied by 100, which is give you the percentage. For 0, it's going to be 0.45 multiplied by 100. So you will add 3 of them. So what you will get? 18.3
First one,
plus
yeah,
30 plus 45. So add them all.
93.33.
93.33%. That is your final result.
Yeah.
Okay, so did you get it, or how did we get 93.3%?
Yeah.
Okay. So this is all for today,
Mhm.
Abdullah.